All right, welcome back. I'm in a different part of my office now. I had to fight the sea monster over here to get over here, so it's been a very challenging day. I'm bleeding on the inside. Okay, this second lecture, the purpose of the second lecture is to give, so the first lecture was to introduce the course and explain how the coursework is going to go. Second lecture is to introduce design in general and what the process of design is. Okay, so this is a very high level, abstract thought video. Yes, some of this content will show up on the quiz for this week. So, pay attention. Take notes. It's always a good idea to take notes in any class. There are no exams in this class, but generally taking notes is a good way to retain the information. Simply the act of taking notes will help you understand, recognize, and recall the information better. One of my nephews is getting a D in one of his classes, and I was like, do you take notes? He's like, no, I don't need to. I'm like, you're getting a D. You gotta do something different. No, I don't need to take notes. Statistically speaking, the students who take notes tend to do better than students who don't. It's never a good idea to just simply disregard. I mean, why are you even watching this video if you're not going to try to recall some information from it? If you have to come back and rewatch this video, anytime you want to glean information from it, you get to listen to me talk about a sea monster and how much I was fighting it. Also, every time I turn around, I mean, I basically show my butt to the camera. You have to watch that repeatedly. I'm gonna have to write like this now. You don't get to see my butt. I swear I'm a professional. I know it doesn't look like it. Don't laugh at your own jokes. I might have something wrong with me. I haven't been diagnosed, but... Luke, you would know. I had a number of emotional breakdowns during your class. Anyways, so what is design? Okay, process of design. Design entails. This marker is dying, so I have to make sure that it's actually showing up on the camera. The process of design requires premeditated thought. I think a couple of those mental breakdowns were your fault, Luke. You and Alex sat in the back of the room, and you guys drove me nuts. It's good times. Those were pre-Rona times. Everything was different pre-Rona. Okay, back to class. So this requires some element of premeditation. What does that mean? It means that you are at some point sitting down and thinking about how this design will interact in the environment that it is intended to be solving the solution in. Okay? So let's say I'm envisioning a whiteboard marker. Okay? At some point I think, this is probably going to have to touch a whiteboard. So I should give some kind of thought to what's going to happen when this touches the whiteboard. If this felt tip, look, I'm poking myself in the face. If this felt tip smashes the first time I touch it to a whiteboard, how useful is that? I tend to write with a very heavy hand. I like to blame it on the fact that my muscles are huge and I just smash everything like the Hulk, just everywhere. No, I have always written with a very heavy hand. I apparently I hated it when I wrote. It was too light to see. Oh, and also I was poor, so I used dull pencils all the time. I get to use mechanical pencils like those rich kids. Dang rich kids. Where's I going with that? Right, I write really heavy all the time. So for me, having a reinforced felt tip is really important, because if I write very heavy, it's going to smash the tip of this pen in, and this now becomes a one-use whiteboard marker, that's not a very good one. A design has to be premeditated. It has to be envisioned working in the environment it is in with the individuals who are going to be using it. Okay? So, someone has to use it somewhere for some length of time and you have to understand that. If you don't know how it's going to be used, you can't design something. Hey, go design me something. I can't promise you I will ever use it. If you come back with a feminine hygiene product, I probably will not be able to use it myself. I don't even know if I would try. But it could be a perfectly great design, but if it's designed for me, I'm not going to be able to use it. Okay? When you design something, it requires premeditation because you have to understand how it's going to be used. At the end of the day, when you solve a math problem, you usually start with a problem, you follow a set algorithm that will guarantee a solution. Okay? So this is not a math problem. Per se. Because I also told all of you that every problem is a math problem, if you just want it to be. But this is not a math problem in the idea that it only has one right answer. Okay? You can in a math problem, you follow an algorithm, it will guarantee you a solution. Sometimes that solution is there is no solution. Design is inherently not a math problem. Because you may follow an algorithm and find a solution that works. You may. You may follow an algorithm and find that there are no solutions. Because it's physically impossible. You may follow an algorithm and you may find 15 different solutions, all viable. That's why it's not a math problem. 2 plus 2 equals 4. It doesn't equal 5, it doesn't equal 3, as much as some people want to try to make that happen. Jeremy, you are in this class. Dang it. Don't you dare. It is not a math problem in the idea that you only get one answer. Okay? A good design problem ends up with multiple answers. And what does it mean to have multiple answers? It means you have to be able to figure out which one is best. And ultimately, what design is you have to answer the question there. What is best? To understand best, you must understand good. To understand good, you must understand baseline competency. Okay? If I have a whiteboard marker, but it sucks, it's still a whiteboard marker because it has baseline competency. If I have a whiteboard marker, and it's pretty good, it is a whiteboard marker that is pretty good. Okay? It has that baseline competency, but it also has attributes that make it good. If I have a whiteboard marker and it's the best, First of all, it has that baseline competency. It is a whiteboard marker. It's not a pencil. I'm not trying to write on this with a pencil. It doesn't matter if it's the best pencil. I need a whiteboard marker. Okay? It has to be the best at solving the problem that is, I need a whiteboard marker. Okay? And to be best means it is good in such that other solutions do not have the kind of goodness that this one has. And that's where it is a math problem, because you can algorithmically compare different designs to each other. Okay? So, when it comes to design, the idea is you have to understand what the problem is that you're solving. You cannot simply end up with only one solution. You're doing the design process wrong if you do that. And lastly, you need to ensure that that solution is the best. Because there are more than one solutions, you have to comparatively identify that it is the best solution. And that is the process of design. Very high level. Okay? Understanding the problem, recognizing the solution base, and then figuring out if the solution that you've chosen is the best. Now, the way that I present the design process in class, all of you have heard this from me if you've taken a class from me, is I use a process that I call PIRA. Okay? Oh no! I will use this whiteboard marker until the second it dies, and then I will discard you into the masses. The first step is problem framing. Now, what do you do as a part of problem framing? As a part of problem framing, you understand the population, you understand, I'll write this down in a second. You understand the basics of what the problem is, okay? In I, you do ideation. This is where you come up with a numerous number of solutions to try to figure out, well, what all possibly could solve the problem. I like to use the example of a light pole. If a light pole can solve your problem, you haven't defined your problem well enough, unless your problem is requiring a light pole. Okay? R, realization. This is the process that is required to take a singular idea and produce a viable result as the outcome. Okay? Ivana says, save the marker. Heck yeah. After you realize, after you build it, after you prototype it and model it, this is, by the way, the process where you do 2D, 3D modeling. Because you have to figure a lot of problems out when you 2D or 3D model something. The last step is analysis. Okay? If you did your problem framing correctly, you understand what makes a solution good. Here, analysis, you come back and you revisit that. And you say, is the solution that I created good? If it's not good, you start over. And that's the process, okay? Now, I'll jump into a little bit more on what each of these means right now. I have like 10 minutes before I'm gonna quit this lecture. I wish I could quit this lecture. So, problem framing. The steps to problem framing are: number 1, you have to identify the population. Okay? Before you even start designing, you need to know who it is that's who has this problem. Okay? If you yourself have an issue with getting out of bed in the morning, you can design something that you personally use to help you get out of bed. It can be custom designed to fit on your bed. It can be custom designed to fit in your shoes if you need it to. It can be custom designed with your favorite songs or playlist. It can be custom tailored directly to you. If you do that, you can guarantee yourself a solution, but that solution will not be valid for most people. Now, to take that, now that said, it's actually really easy to design for one person. To design for 5 people, if they have similar tastes in music, oh, let's just use those similar tastes in music. They have similar beds, they have similar shoes, they live in a similar location, they speak a similar language. Similarities make it a lot easier to... Markers are people too. The similarities make it a lot easier to design for that group. Okay? The bigger the population you try to design for, the harder the problem becomes. Because you have to try to meet multiple needs, each of which are different culturally, based on language, based on location, based on what kind of existing houses they live in, what kind of worlds they live in, what kind of environments they're using your device in. The larger the population base, the harder your device is. I can tell you that devices like the iPhone were not developed for everyone. They were developed for healthy individuals. They were developed for people who have good eyesight. They were developed for people who have hands. Most specifically, people who have 2 hands. The iPhone itself was not designed to be a disability enabling device. Now, there have been people who have created add-ons for the iPhone that have allowed the iPhone to be used by people who are quadriplegics, by people who do not have good control over their hands, by people who are blind. There are additional add-ons that can be used on a device, but the device itself was not intended for everyone. And for them to design for everyone would have made the problem solution much different, such that the problem solution itself may not have been desirable by the general population. And it's sad to think, but that's how we live. Pants. Pants were designed for people who have 2 legs. They are much less convenient for people who only have 1 leg. They're much less convenient for people who have 3 legs. We're not designed for everyone. It was designed for a specific target market. And understanding your population changes everything about your design. Because the next step is to establish... Luke, I'm about to throw this people away. It's too late. We'll say a funeral. You were a good marker. I used you to write all over my board. Goodbye. And quickly replaced. So, 2. Oh, look at how... See how much prettier that is? Ah, it's gorgeous. I don't miss you at all. The second step is to identify the constraints and the functional requirements. Okay, every population has a certain definition of what a product is. Okay. I'm sorry, Ivana. It had to be done. I can give it to you in class next week if you need it. Every problem has a definition of what the solution is. Okay? A whiteboard marker has to be able to leave an erasable mark on a whiteboard surface. That is the definition. There are a number of constraints in that. One, it has to use something that can be erased. That's a constraint. It has to use something that can be applied. That's another constraint. It has to itself be reusable or have a definite lifespan. This has a lifespan. Obviously so, because I threw it away. But everything also has to be able to do something. Okay, so it has to have a constraint. Constraint for a whiteboard marker has to be erasable. Functional requirement has to leave something. Functional requirements are action verbs. They are things that are actively done. Constraints are a yes-no condition, okay? Is it erasable? Yes or no. There is no maybe. If it's mostly erasable, it's erasable. If it's not barely erasable, it's not erasable, okay? And that is left up to, oh man. I am not hosting a marker funeral on my, I'm trying to teach class here. It was a good marker. I used him like a pet. I smashed him against many boards. This is awful. Anyways, constraints are yes-no conditions. Does it solve the problem? Does it not? Does it apply? Does it not? Okay? If I have a whiteboard marker but I can't fit it through a door, I'm not going to be able to write on a board with it. Okay? This is again where, does a light pole fit into it? No. It has to be small enough that I can hold it in my hand. Okay? And that is a functional requirement. It has to be hand-sized. Okay? That's not a functional requirement. That's a constraint. Sorry. 3. Now that we have defined the problem, because that's what that step is defining, it is creating a definition of the problem. I will host a funeral when class is over so that I don't break your hearts with my heartfelt crying. I would hate to do that. So, this is getting out of hand. Marker writes. The third step is identifying measures of quality. Okay, now what a measure of quality is how do we know what is good? What can you measure about something that you can use to compare against other solutions? So if we're talking about whiteboard markers here, measure of quality is how much of it erases when you swipe over. Let's say you swipe over it once with a clean cotton cloth, applying 1 psi of pressure evenly across the cloth. Okay, does it erase nicely? You can come up with a volumetric amount of how much is left over after one swipe. You can come up with a testing methodology for that. And quite frankly, people do. That's how quality assurance works. And now they have a physical quantity by which they can compare different whiteboard markers to each other. And that's one measure of quality. And you can call it erasability. You can call it whatever you want. You can call it funability if you really want. You're coming up with a definition of how to create that test. You get the ability to define that term. Okay? You guys suck. I need to turn off comments. Thank you, Mason, for now joining in with the audience members and denouncing me for throwing away a useless whiteboard marker. Oh no. I better finish class before I get fired. Okay, so once you've established measures of quality, again, these are measurable values by which you can compare different solutions. Okay, you can establish your own testing methodology for each measurable value, but your list of measures of quality ultimately define the goodness of your solution. The fourth step in this is you need to understand what existing solutions are. This is going out and looking at where you can buy existing whiteboard markers. Okay, doing the measures of quality tests on them if necessary, because the fifth step is does. Use the word does. Is a new solution needed? If you have a whiteboard marker that satisfies the problem already, which it does, why not use it? Would it be more cost effective to just use an existing solution, or do you need to design another one? If you need to design another one, you're going to have to pay people, you're going to have to put up a manufacturing facility, you're going to have to design everything that goes into it. If it doesn't solve the problem well enough, then you have to design a new one, okay? And do you see an opportunity by which you can improve on it? Then you can advance the solution. And this is ultimately where the meat of the engineering design process comes from. If you can effectively, in confidence, answer number 5 of problem framing, you can be a great engineer. That's it. That's all it takes. It's this answer. Is a new solution needed? Because if the answer is no, you've done a great thing. You've saved your company millions of dollars. If the answer is yes, you've done a great thing. You have made your company millions of dollars, or you advance the state of technology of the world. Both of which are very useful. Okay, so problem framing, step 1. Ideation, step 2. This is where you just come up with a list. All possible solutions, and we'll talk about this later in the semester. Talk about all possible solutions. And then 2, you narrow them down. How do you narrow them down? By first of all checking to make sure that they solve the problem. If they do solve the problem, then you rate them on goodness and compare them to each other. Okay? Some of them you can throw out right away. Anything that's the size of a light pole is going to be a terrible whiteboard marker because it's very difficult to maneuver. You can say maneuverability is the amount of time it takes to write the word anti-disestablishmentarianism. That could be your test. If somebody can write it very quickly, high score of maneuverability. If somebody takes forever to write it, that's a very low score of maneuverability. Okay? And you could have the same person do it, but that's the kind of measurable quantities we do. After looking at them very quickly, you can figure out how to narrow them down. Once you have your ideation done, then you move into your realization phase. For realization, what you do is you model. You come up with models. You build a prototype. You come up with the solutions. You take your ideas, you put them to form. You put the math into them. You see how realistic they are. You find out how much they're going to cost. You fully evaluate them, pointing at 4, which meant 3, to figure out their measures of quality. Okay? By coming up with different types of models. For the last step, you take the different ones that you have, you bring it back to step 4, where you evaluated existing solutions, and you compare what you came up with to this. Is there something you can improve about your design that will make it better than the existing solutions? If so, you go back into a really swift redesign package where you say, okay, new problem, we need to make sure it does this. Okay, new idea has this, great. Realize, build a new prototype, go to analyze, better than the existing solution. You now have marketable product. You now have something that benefits the people that you're working on. So this is the design process, and every design process involves some substantial amount of research, a little bit of idea generation, a whole lot of time spent building, and then a lot of work analyzing and communicating those results. Communication is a huge part of engineering. You follow all of these, you'll be a great engineer. That's it. There is no calculus secret to being a great engineer. The secret is how well you can follow this process. Okay? We're going to be following this process twice this semester as part of a group. And you're going to show how well you can follow this design process. And we'll talk about different aspects, how to effectively find measures of quality, how to really well define constraints and functional requirements, how to compare solutions using Q matrices. We'll do all of that. We'll get there. You know, we have a whole semester to learn. We're not going to do it all on day 1. Now, this lecture is over. I am going to see you on Thursday. We'll go ahead and do this again on Thursday. I'm going to try to split the class into Tuesday, Thursday sections. hopefully before Thursday, maybe after Thursday, depending on how busy the rest of my week is. But you will know. And what we will do next week is I'm going to figure out a time when I'm going to live stream the lectures for this class, because apparently you guys like showing up on YouTube and chastising me for throwing away whiteboard markers, which you will be able to do that as a whole class. Great. I'm not walking into this at all. But I will let you know when I will be live streaming. You don't have to watch it live. If it doesn't work for you, you can always watch it later and chastise me in an email, okay? Or ask follow-up questions, that sort of thing. But I will try to get my live streaming done at a different time. It may be right before this class. It may be on Monday, Wednesday, or Friday sometime. But I will find a time for that. I will let you know, and I'm going to try to figure that out by Thursday. So until then, I will see you Thursday at 2:30. And at that point, I will give you assignments that will be due next Thursday, because your assignments will be given to you on Thursday and due the following Thursday. I only believe in weekly assignments, so no homework due this Thursday. It'll be due next Thursday at the soonest. All right. Good talk. I'm going to go hold a funeral.